All right, so let's continue. So I was here. We continue with error handling, looking at boxing errors. This is the Rust language reference. We're doing this because we want to continue with Rust links, yeah. And one of the last requirement here is like boxing errors. So we're going through it, yeah. So um, in the in this chapter, when we talk about boxing errors, it's really about using smart pointers as a way to convert errors from one type to a generic type that we maybe declared or created. So we have a result type alias that we created here, which is either a standard result of which has a generic OK value or a boxed in error. So this can hold different types of errors, basically. And I did that one of the use cases for box type, and yeah. So we wrote this program. So let's see, which is equivalent to what's there, right? So yeah, let's. So that this is it here. We have the type. Wait, no. Let me clean up what we had from before, and we don't need this. We have an empty vec. We implement display for the empty vec. We implement trait display and implement error trait for it, so we can uh do the conversion. So because like our type here, which the type here says um, it's a result of generic OK type, OK value, or I mean in the error variant, it can be an error, right? It can be error. So so the fact that uh, we implement error for empty vec, it means we can convert empty vec to error. Yeah, that's what it means. And then that's how we do it here, where we basically in the double first method of yeah or function, sorry, double first function, we take a vector of string slices or reference to string slices. We get the first element there or first item there, which is an option, and then which gives an option type, and we do OK or else. Yeah. So this would be a function, which is basically us passing the error, passing the function that should be in the error, right? So that this is going to be so. This is the function that would convert. This is the function that would just basically give us create an empty vec for us, right? Uh, Empty vec that obviously is an error because error is implemented for it, and then we do the and then function here where we basically take what is in the OK variant, which is val here, which is this reference to a string slice, which is that first thing that was in the option. Then we parse it. If it fails, we just map the error, and we use the error dot into. We just call it into. So into knows how to convert the error from its type to the uh, error type here, and that's what I wanted to check, like how into works, how the dot into is a trait, I believe. Yeah. So exactly, this is it here. Is a trait. This is the trait, and this is the trait method. So this is the into trait, and so it does a value to value conversion that consumes the input value. It's the opposite of from. Exactly. So from is also a trait that uses the from method to convert things as well. And then this is the opposite of from. So you should prefer using into over from when specifying trait bounds on generic functions to ensure that the type that only implements into can be used as well. Mm. So one should avoid implementing into and implement from instead. Anyway, okay, so this is how it works. Examples. In order to express that we want a generic, so the string implements into vec uact u8, sorry. In order to express that we want a generic function, take all arguments that can be converted to a specific type T. We can use a trait bound of into and then the generic here. For example, the function is hello takes all arguments that can be converted into a vector of type U8. So is hello, we define the generic type here and say that it has to be, we use a trait bound to specify that it will be, okay, that it has to be into, that implement, into vec U8, and then we say s of this type, okay? And then what we say let bytes be this byte of hello, and then we call and then we do to vec. Yeah, we get a vector of that, and then of okay of the UA type here, and then we will call that into. Yeah, we then see that would and we do that. Okay, here. I mean, like this is just the function itself. So I set this, and this is actually where we call it from, doing hello dot to string, and we see that string implements that. Okay. Anyway, that's fine. Okay. We got it so far, I believe. I mean, yeah. So let's move on to the next one. Now, other uses of question mark operator. Notice in the previous example that our immediate reaction to calling parse is to map the error from a library error into a boxed error. Yeah, yeah. So that's like using the map error. Yes, that's this now. Since this is a simple and common operation, it would be efficient if this could be elided. Alas, because and then is not sufficiently flexible, it cannot. Okay. Okay. Like, yeah. So it would be nice if we don't have to do this. So because when you call um parse, we then have to do, wait, this is going to be, what do we have here? Actually. Anyway, the format is like, I would want this to be different. I would want this to be like so. Uh, it removes it. I mean, I think this, I would like the formatter to, I would like to adjust the format actually. I want to see this like, the and then it's not, see, look, I have to, anyway, I do actually to format it, but this is one thing. So I do a dot parse, and then I call it map error after it, which will do this, and then it will do a map in the end. Okay, but that's different from what is here, right? This is going to parse and then call and then do a map on what it parses. So it's also okay. So basically, okay, let's see. So what you say is like dot and then um Okay. Exactly. Yeah. That's also something that we could do. And this was how I wanted. I was doing it. I was gonna do it earlier. So you have right now you have a result that you can do a. So let's say I do this now. You have a result that you can do a dot map. I mean, you can actually do a map error on, and then say uh, this is going to map the error. Yeah. So to the into here. Yep. And then you can do the map that will take the actual the value now. Because yeah, map does okay to okay to okay. Uh, yeah. So you can do this and then now do n times two. And what is the problem? Okay, so this cannot be, wait, this can be converted, yes? So, okay, this would not work here. And because map is going to map for you the value unless you do uh okay, sorry, unless you do okay and then you're returning something like this. Come on, right? No, 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 no. What's the issue? And use the question mark operator to extract result. And i- this would be okay. I mean, this is going to give you okay. What is wrong here, actually? I mean, I want to use it like this. I want to see why can't I do this? This already gives me a result into it, and then because like that's what this is. Oh, wait, I want to see why I cannot do this result. I think to unknown. Use the question mark operator to extract the result. Why do I want to extract the result? Because what I want to return is a result of that type. Yeah. Expected result I32 and box. Yeah. Okay. Okay. Expected result and this found result and result. Okay. So okay. So this would be exactly. So if I do not return this, then you say this would be okay. This is correct. This is returning me the result. It's just doing the map. Okay. Then why is this one complaining here at this point? Because this is a what, a passing error. Is that the problem? Yep. This is not able to be converted. Why? So the trade bound passing error from NTB is not satisfied. The trade the trade from MTVEC is not implemented for passing error. So okay, I think okay, the trade from, but we are doing into. Why do we need from? From. I don't know the signature of from. I need to check. Wait, I don't need to do that. I can keep this as, why can't we keep this as empty? What would be wrong? What would break? Oh, we need to implement that. Okay. Yeah. Okay. No, it's like from is valid to self. This would be default, yeah? Okay. But do we have to then implement? Give me an example of from. Okay. Yeah. Um, yeah. It's generic, right? So it's passing the error, and I want to say from an error that is a passing error, and then it should return um yeah, empty vec is an error, right? So it should just return for me empty vec. Why not? Why is this still complaining? I thought you said from was not implemented. The trait from empty vec is not implemented for passing error, which is required by empty vec into, but I just implemented uh, from passing error for empty vec. It's exactly what I did. Uh, hmm, let's read the error again. Mhm. So this is where it's complaining. The trait from empty vec is not implemented for passing error. Oh wait. Ah, okay. I read it wrong. So no, what it's saying is that the from, so like there's no so passing error does not have an implementation uh that can convert a from NTVEC to passing error, which is required by NTVEC into. Okay, note required for NTVEC to implement into passing error. Okay, so the way we can do that. Wait, sorry, required for NTVEC to implement into. So wait, if we implement into passing error, will it work the other way? Okay, that would be interesting. I want to try that. So, what you're saying is that, are you saying if we implement into percent error for MTVEC and we then implement into, wait, don't we have, okay, we don't have that here. By the way, we don't need this. Let's see into again. The trait method into self. So you basically have like fn into um, self, yeah. And then it goes to do, no, I think it's in the wrong place, right? We did not, this was not, it's not here. It's supposed to be here. So you have like f into self, and it's supposed to give you in this case. Hold on. Hmm. But this doesn't make sense. What I want to do is, so I want to convert I want to convert an empty convert a passing error. Uh, I want to convert from a passing error to an empty vec. If I do into like this, into would be okay, taking a passing error and converting it to an empty vec. Is that what it's going to be doing? Okay, I mean, into is the inverse is the inverse or opposite of uh, of from. So, if, and that, I mean, according to what they say, then it should work. Let's see. Just a second. Okay, let's see. Um, Passing term. Right. So if it does that, then is it? Yeah. T. It's going to return C here, whatever this is. Do you have me an example here? So you have this implementation where you have into cells. I don't know if this should be the correct way. Yeah, this. Uh, what happens if I don't have the implementation? I only have like so. Yeah, you need to implement it, of course. Oh yeah. I think string has one implementation. Let's see. I think it will be under into calls you from self. So you have a conversion from one type, but not from a certain type here. Okay, do that. Yeah, from and into is reflexive. This is what I would expect actually. So basically, if we do from, we should be able to use the other one, right? I mean, it should work. Uh, but then are we supposed to be returning? So if we say into parsing error for empty vec, what's the error message we saw here? Let's just read it again. So the trait from empty vec is not implemented for parsing error, which is required by empty vec. Not required by required for empty vec to implement into parse in error. Yeah. So each pass there for empty vec should return into, and then it should take self and return a passing error. Now, how do we create the passing error? So it's easier to just create the struct, then into here, get a try into and try from, and returns an error. Doesn't give me a passing error. This is a different type of error. How do I create a passing error, man? Anyway, okay, I think I give up on this part. I'm not sure how we will do this one. I think I was gonna try that out when I mean, we spent too much on that already. Instead, what we know of is that this would work for us if we don't do this. Wait, if we don't do this, don't do this, don't do this, and instead do this we had before, we know this would work. Yeah, I was just trying a different approach. It already works anyway. I was trying a different approach, but yeah, I guess we got stuck there at that point. I would look at it again and see what we probably were missing. Yeah, because it looks like it should work because it's able to be converted from here already. But if instead you say map or map error, then that's where you have the problem. Anyway, that's fine. I can take a look at it later on. Let's continue with this instead. So other uses of question mark operator. Um, so this would have been better, it would have been easier if it were elided, is what they say here. Since so you cannot do this with and then is what they're saying, but instead you can. I think it was suggested for us to also use the question mark operator. So because and then is not sufficiently flexible, it cannot. However, we can instead use the question mark operator. Question mark operator was previously displayed as either as unwrap or return error. This is mostly true. It actually means unwrap or return error from. Yeah, so it will call the from. That's the more particular way it works. Yeah, since since from yeah since from is a conversion utility between different types. This means if you use the question mark operator where the error is convertible to the return type, it will convert automatically. Yeah, makes sense. So here we will write the previous example. Now using the question mark operator, as a result, map error will go away when from is implemented for our error type. So basically, what would you have? You would have okay, this interesting. Um, yeah, so you have first, which is okay, or the empty vec with the question mark operator. So you short circuit it, and then it gives you the okay variant or the error immediately. And then you do a parse again, which gives you that or the error immediately to come. It will automatically convert whatever error to that to the error we have, and then you just do okay, this and pass. Yeah, this is some kind of thing that I would expect. This is just unnecessarily difficult to read. So let's write that. Let's write that. So we have first, let's first be vec dot first question mark. So it would like we're saying give me the first value you have there or throw, yeah? And let parse be first dot parse, and then give me the first or throw. I mean, give me the first or convert immediately. Yep. And this is parsed. It's like this is much simpler. Anyway, it's good that we also we're doing around. Just think the hard stuff first. No, I don't. I don't. Pain is not good. I don't like pain. And then now we will return. Okay, and we will do two times parse and what is it now? So the question mark operator can only be used with on results, not on results, not options in a function that returns. Yes, that's true. So because this should actually do this is an option. Yeah, my bad. It should be okay or right. Yeah, and then now it would. It's now. Now we can do this. Okay. Yeah, because that doesn't know how to convert that to the same type. Okay, that's fine. I mean, much easier. Come on. Okay, I think just want to show us all of those things. And it's actually fair and clean compared to the original with Panic. It's much similar to replacing app calls, except that a result must be destructured. Wait, it's actually fairly clean now compared to the original Panic. It's very much very similar to replacing the unwrap calls with question mark, except that the return types are results, and as a result, they must be destructured at the top level. Yeah, yeah, it's very similar to using unwrap. Yeah, okay, so that's fine. Next, wrapping errors. See, we're almost done. We can do we can do the rustlings maybe tomorrow, or I don't know, maybe today, I don't know. So wrapping errors. What's time? Okay. Oh no no no! I need to run. Okay, so let's wrap this up now. An alternative to boxing errors is to wrap them in your own concrete type, in your own error type, sorry. So we have our type, like so. We have the double error, which is our type. And what now? We have enum double error. We have empty vec here. We will defer to parse error implementation for the or error, supplying extra info required adding modifiers. We will defer to the parse error implementation for their error. Okay, supplying extra info requires adding more data to the type. So we have a parse. Um, I mean, parse is a variant of the double error, and then we give it a parsing error here. Implement display. We match this, and then we also implement error for we implement error for double error. It's called actually called double error here. Yes. Okay. Okay. I think I need to go. I think let's continue tomorrow. I also just realize I need to do something very quickly. So yeah. Um, I think we will just continue from here tomorrow. Yeah. we'll write this program and then we'll go over what's happening here. And I think we should be able to also, and since that's like the one before the last, we should be able to, I think we should be able to do the Rust links. Yeah, I'll start the Rust links tomorrow. Maybe we'll do like one, two, or three of them. All right, then have a good evening.